Good evening, everyone. I'm Devesh Lathi from the Next Genius Scholarship Program, and I welcome all of you to this webinar with Curiosity Gym. Uh, we are conducting this online webinar series, calling it the Online Profile Building Webinars. A little bit about the Next Genius Foundation. The Next Genius is a registered charitable trust, and we help high school students with scholarships for their undergraduate education in the US. Over the past 5 years, we have helped around 117 students with scholarships for their education in the US, and these 117 scholars are now pursuing their undergraduate at one of the Next Genius colleges. We also have 3 of our scholars already graduated from college this year. The application for our scholarship program is already open, and I invite grade 12 students or gap year students to apply to us online on our website, nextgenius.com. So a little bit about the profile building fair. When you apply to college, the colleges across the world, primarily in the US, or you can look at your application in a holistic manner. Look not just at your high school scores or at your testing scores, but as Dr. Mandana said in the previous webinar, they look at the other extracurricular activities that you do. So this was one of the most important reasons that we brought together this online profile building fair, where we invited organizations from across India and across the world to talk about what other opportunities students have, demonstrate and to differentiate themselves from from the other applicants who are applying to selective colleges up in the US or other countries. So that's what brings us to the current session, where we have Mr. Girish Nair from Curiosity Gym. Curiosity Gym is again a very interesting platform where students who are, and as the name suggests, you are very curious, who want to learn something new, something in the field of coding or 3D printing, or maybe digital uh, electronics and things like that. So it's a great platform, and STEM students or some of the non-STEM students who are interested in creating something new, building new projects, can benefit greatly from this. So without any further ado, I invite Mr. Nair to take control of the screen and begin his presentation.
Thank you, Devesh. Give me a second. Okay, so can you see my screen?
Yes. Okay. Yes.
So before I show the screen, let me just say hello to all of y'all. So I'm the founder of Curiosity Gym, and Curiosity Gym is a space that it is one of the first maker spaces in India, in Bombay. There were a few others, but we were focusing on education, right? So while maker spaces, the maker movement was a movement about, a lot about making things, and being a parent myself, I'd set up a Curiosity Gym to in a way change the way education is done, and so to make it interesting for students to learn. Okay, so one second. So yeah, so Curiosity Gym, at Curiosity Gym, can you see my screen? Yeah.
Yes.
So we have an integrated learning experience there, and we have mentorships in various subjects, right? The subjects may be things like rapid prototyping and 3D printing. It may be on coding, on mobile app development, on robotics, on data visualization, on physics, Internet of Things, electronics, and also in bioinformatics, right? So we have a wide spectrum of areas in the areas of STEAM that we have mentorships for. And our team is a team of very qualified makers and educators. Most of us have been at different universities like IIT Bombay, Stanford, Virginia Tech, IIM Ahmedabad, TIFR, Homi Baba, Center of Science and Education, Symbiosis, etc. Right. So we have a very strong team of mentors. Some of the mentors have worked several years in industry, including in Silicon Valley and even in India, running companies. Uh, I myself used to run the automation group at Intel for several years, and also had probably run one of the world's first e-commerce distribution center for food. So while you look at the Swiggies and the Zomatos of today, we had kind of done that about 20 years ago in Silicon Valley. So that is my own background. But the team has a background also of having setting, national Olympiads in physics or in biology, and it's a very strong team. And we've been setting up something called innovation hubs in schools. All right. And we also have a design thinking hub that we run at a leading MBA college at SPJIMR in Bombay, where we run a design thinking hub where even college students can come and make prototypes. They have an idea they want to make, they can come and make it there. Right. So we give all the guidance on that. Yeah, a little background on my other co-founder, Jahangir. Yeah, he's an industry veteran in technology and embedded systems. And he's an expert on IoT. And so he used to run R&D for CMS Computers, which was one of India's first automation companies. So a lot of times, even before IoT had become coined as a term, and so a lot of the early automation was done by Jahangir as head of R&D of that premier company, right? We were also the first organization to set up an innovation hub within the school timetable in leading schools like Cathedral and many other schools in Bombay. And we are now expanding to several other cities as well. We have over 100,000 student hours of contact, and many of our students have been placed at many of the top universities around the world, including the Ivy Leagues. I'll come to that later. Now, I think that Devesh, you had mentioned that besides students attending the seminar, there were also some, school and career counselors. So I just thought I'll kind of a little bit of a background of who we are and what we do. The green boxes are mostly catered to the mentorship. So most of the audience is focused on the research oriented social action mentorship, or it could be making a prototype, all of these things. So students come to us for this, and also we also have a lot of workshops that you can go to our website, or different courses that we're now doing online. So it's called Curiosity at Home, because during the pandemic, besides doing our programs that we call innovation hubs in schools, we have the same offerings that can be done. These are all instructor-led sessions that can be attended from home. Right. We also run a design thinking hub, as I said, in a college, and for schools also we have a product that we call Curiosity in a Box. So even for teachers of schools, we have a lot of STEM curriculum that we've developed over the past 5 years. And so that's a kind of a package product that teachers can use to deliver even in an online method. And the expertise, as I think I said before, is various aspects of STEM: physics, biology, electronics are the three main things, along with robotics, that we're really good at. And we can give research guidance, project-based outcomes, and all of this. So really, what really happens in these mentorships, right? Usually students between grade 8 to 12. A large majority usually is in the 10th, 11th, 12th grade, but sometimes students start earlier, right? They come for a one-on-one mentorship program, where we sometimes there's a skill development phase where they are learning how to use a 3D printer, learning how to prototype as a workshop prior to the mentorship. But then, post them getting some of those skills, we kind of identify a problem, co-work on a problem, right? If the student already has an idea of a problem, then we can dive right in. If the student needs help in identifying a problem, we can, brainstorm with him, and within 2 or 3 weeks, usually we can 2 or 3 sessions, we can try and identify a problem. Then we guide on the research, then guide on the designing and prototyping. So the mentorships range between six weeks to, there are some students who've been with us for 2 years as well, right? And for the schools, what we have is, so some of the IB schools have a CAS club called a social action club. So we have a social action club that we run. We run a advanced robotics club. We run a innovation design and entrepreneurship club that we've done in several of these schools, usually for the 11th and 12th graders. Right. Now, this is an example. This is from the website, from the UN website, where many of you all may be knowing already that there's the UN Sustainable Development Goals. So some students want to work on projects that will help in addressing one or more of these issues, right? And sometimes the same solution may hit 2 or 3 issues, right? And that's why I'm saying it's one or more of these issues, because it may have a little bit of something in number 3 and a little bit of something in number 2, for example, and if it's a health, right? So then they do research on it. They may design and prototype it. A lot of times it might be a process solution, or it might be actually a physical product as well, right? So you can try and become a global problem solver, and especially in the pandemic, in this this era where almost everyone is at home, there's the great opportunity for actually innovation, right? Because usually mankind has innovated when there's a lot of challenges. So today the world is going through a lot of challenge, right? We are all stuck at home, and even if there's the lockdown opens, there's social distancing, all kinds of things. We have to reimagine almost every single industry, right? So and still the earth has a lot of problems of sustainability. So it's an excellent time for actually sitting down, using time well to do some research, get some guidance, and maybe even do a prototype, write a paper, and help build your college profile. These are some of the examples of the students that we mentored in the past, right? And so, for example, Gaurav Goyal, he did a predictive model, and he was admitted to Harvard. He also came, I think he was a 12th standard topper a year or two ago in Maharashtra. Anushka made a stick for the visually impaired, and she went to Carnegie Mellon. Aditya Nair did something on drone visibility for airports to figure out where, when can planes land and all based on a camera on a drone. Then Ishita made a waste segregator model, and Raghav, who got into Berkeley, and also submitted his project for Google Science Fair. He didn't win, but at least they made an entry on an energy harvester. And so these are some of our success stories. So now it's kind of quiz time, right? So maybe I ask my colleague Bhagashri to send y'all. So Devesh, can you run the quiz?
Yes, right. So I'll start the first one.
Yeah. So.
Okay, it's on.
Yes. So this is a picture, and you've got to identify this product. Okay. What is this product?
Okay, people have started answering. I've started receiving responses.
Yes.
Okay, I'll give another 15 seconds.
So what is the product? And once you answered, you have to say finish poll, right?
Yes. Okay. So I'm just ending the poll now.
Yes.
And do you want to open the results?
Yeah.
Okay. So I'll share the results now.
Yeah.
So this is what it looks like.
32% or 39% of you all said it is a sewage pipe cleaner, 10% a floor cleaner, 52% a window cleaning robot, 0% a robotic toy. Okay. So let me show you exactly what it was. So the right answer was it is a
Manual
sewage
scavenging
cleaner.
is lifting and removal of human waste manually from sewage pipes, pit latrines, and drains. Manual scavengers mainly scrape the waste with their bare hands without any protective gear or masks. Over 20,500 people have been identified as involved in manual scavenging in India. Though prohibited by legislation, it continues to be a huge problem. I channeled my love for robotics and innovation into finding a solution to this problem. I built a pipe cleaning robot out of easily available, inexpensive materials like PVC pipes, a 3D printed chassis, aluminium plates for reinforcements, as well as a few electronics and DC motors. I have used bearings to separate the body of the bot from the brush component to allow for rotational movement of the brush, which would allow it to clean it as it went along. I used the dual shaft motors to allow for the forward and backward motion of the brush for movement within the pipe, and a DC motor along with the bearings for the brush rotation to clean it as it went along. The robot that I prototyped was tested in a makeshift sewage pipe made using hardened veneer sheet. I specifically chose the components that I used to build the pipe cleaning robot and the ratings for all DC motors that I have used. After testing my prototype, I have found that the robot was successfully able to navigate the makeshift pipe. Perhaps we are closer to putting an end to this dehumanizing profession.
So as you can see, this was one of our students. He worked with us for about a year, and to make this prototype. The whole thing was done in our makerspace, right? And yeah, so this is one example of what one of our students did. Here's another, the second poll, Devesh.
Yes. So the poll is on. And I've started receiving responses. Another 10 seconds before I end the polling. Okay. So this is what it looks like.
Okay, 87% of y'all got it right. I'm glad to see that almost all of y'all are attempting. Yeah.
Great.
So yes, so this was actually a prototype that was done by a group of girls at Cathedral as part of their CAS club, right? So we had an innovation, design, and entrepreneurship club that we mentored. One of the early prototypes is what this girl Malini is describing in the picture on the left. They got covered in the news. They did a crowdfunding campaign. They actually made two prototypes, one with the violet thing with the the red things inside. That was an early prototype which they had 3D printed. Then they got it done in acrylic and they had it painted. They talked to where and they did some Arduino programming to move the spring inside the dispenser, right? So all of that was done over the course of a term, right? And then they also did a crowdfunding campaign. They raised $2,700, and they decided to use that to install 13 machines that they bought from outside to 13 municipal schools, right? So they had innovation as part of it, design as part of the course, entrepreneurship, marketing, all of these were covered as part of the course, and all of them got into very good colleges. Some of them went to USC, one of them went to UK to a medical school, and the other one went to, I think, one of the UCs. This is this is the third poll. What is this now?
Launch the poll now.
Yeah. What's the purpose of these blocks?
Another 10 seconds.
Yeah. This student actually filed for a patent. That's a hint.
Wow. Okay. So here are the results.
Okay. So in this one, building blocks, yeah, it is correct. But actually the answer is, in fact, it came second last, the coral reef. Okay. So I'll just show you. How is this a coral reef? So this one of our students, Siddharth Pillai, right? He was an avid scuba diver, So and then he found that near Pondicherry, the coral was actually, because of erosion, it was depleting, right? So then he came to us and we worked with him on prototypes. And then the initial prototype was done on a 3D printer. Then later on, he used a different material, resin. He worked with another oceanographic organization as well, right? And then they went and actually installed this in the sea. And then about 4 or 5 months later, they went again and they found coral growing. And this is the picture on the right hand side is where coral had started growing on where they'd installed the thing. So he actually, he had also raised about 2 lakhs in a crowdfunding campaign to, pay for all of this. And he's also filed for a patent, and it's a patent pending thing. So you could look him up. He's also covered in the Hindustan Times and stuff. Yeah, this is also an interesting project. What is this? The next poll.
Yes. Okay, the polling is on. And people have started answering.
Also, is there a question from one of the viewers? In the Q&A, I see one.
Yeah. Okay. Maybe you can explain that to them.
Yeah. So the question, I actually can't see it for some reason.
Oh, okay. Just a second. I'll just end this polling.
Yeah.
And I'll share the results. Okay.
So what is this? Yeah, game for the visually impaired. 93% of y'all got it right. Okay. So yeah, some of y'all saw the braille on the top, right? So that was a giveaway. But yeah, so let me show you how this works. So these were 3 boys from a school in Bombay. So it's a robotic voice. So imagine like you're playing KBC, and there's a question that the box throws you, and then you have to say A. If there are different cards, one for A, B, or C, and then depending on which card you put in, it will say whether you're right or wrong. Right?
How it will be easy for a visually impaired person to identify each of how to identify his or her position in the game. So we've got our instructions written in braille over here, and we've also got arrows pointing towards the specific stations. We've got a lock in place over here so that the drawer doesn't fall open. Also, the game has been 3D printed and programmed by us and with the help of Curiosity Chip. And we've also laid an acrylic sheet on top to have a final finish. So basically, yeah, we've basically made the game as simple as possible for us. And yeah, for the visually impaired people. Yeah.
Okay, I'll stop there. And their goal was to actually manufacture this product at reasonable cost, right? So we put them in touch with vendors, but then based on the time they have available from school, they can decide whether to actually manufacture this and donate it to schools for the blind or visually impaired. Okay, this is one of our last polls. What is this? This is a little harder, perhaps.
Okay. I've launched the poll.
Okay. A measurement device in insect catcher an ion thruster, and none of the above. Okay, 10 more seconds.
Yes. Okay. So here are the results.
Okay. So this time also, I think most of you all got it right. So 56% said it's an ion thruster. Yeah. So, yeah. So those of you who don't know what an ion thruster is, it's actually used, potentially it's used in spacecraft to fine tune movement. So imagine there are two kind of knobs. One is a coarse knob to get from here to the moon, and then the fine tuning, the last half a degree of this thing of how the spacecraft should land. So they can actually use ion thrusters to fine tune the direction of movement. Right? So basically, you're sparking those nails on the left hand side with very, very high voltage, right? And because of that, even in a relatively this thing vacuum, the thing will move back on a slide. This is just a prototype, of course, but it needs a lot of safety, of course, and you learn about electricity and things. It's not a coding project, but it's both a mechanical and a physics type of project. Yeah. So this is a tabletop ion thruster. I think I told you a little bit about the girl who had made a waste segregator who had gone to CMU. So this is the waste segregator prototype, right? It has a conveyor belt, and it has a camera on top, and then it can identify the kind of uh, material that's passing through it, right? This is the other girl. I think she got into Cornell. It made a stick assist for the visually impaired, right? So again, to summarize, we have mentorships in many things: in electronics, in coding, in mobiles, in robotics, in data visualization, and in bioinformatics, and also in socially relevant goals, right? In let's say tracing the origin of the SARS-CoV-2, right? We have a very strong bioinformatics team. In fact, the two other panelists, Bhageshri and Preeti, are both have uh, you know uh, 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 either double masters in bioinformatics or biotech, or in B.Ed in bioinformatics. We have another person with a PhD in bioinformatics. So a very strong team who can guide you on all of this. So yeah, I now go to the question answer, and I'll open it up to any questions that y'all can want to post.
Wonderful. Thank
And
you
if you
so much.
want to contact us, this is our contact information. You can email us at explore@curiositygym.com or call the number on the right-hand side. Yeah.
That's great. So, first of all, thank you so much, Mr. Nair, for sharing this wonderful presentation and for inspiring us. I'm myself an engineer, and that too, I also studied bioinformatics. So,
Okay.
it's good to see that, of course, all the other projects were mostly related to electronics or electrical or mechanical parts. But yeah, I would be interested in learning a little more about projects that you're doing in bioinformatics.
Yeah.
So I can see there are questions which are coming up now. So the first question here is, what is the best way to get involved in activities related to aviation in high school? Do you have something in that?
Okay, we don't have any aviation things in this thing because, of course, you need the space and things. We actually started Curiosity Gym with doing things in drones, actually. So we used to have drone workshops. In fact, our first workshop that we ever had was a drone workshop. So we do have expertise in building drones and the electronics, and maybe building even a 3D printed drone. Nowadays in India, the laws of flying drones have become very restrictive. So you can fly a drone only about 200 feet and below. And so, and it's also a little bit of an expensive hobby, but yeah, so we currently don't have a mentor who can mentor in aeronautics, but we have mentors in physics, in any of the biology fields, including bioinformatics, or in electronics or coding.
Okay, wonderful. So, what is the age group for which your projects, programs are most suitable for?
Yeah, it's mostly from, I would say the sweet spot is grade 10, 11, 12, and then early students start in grade 8 and 9.
Okay, and how can the students enroll for one of your programs?
Yeah, they can write to us at explore@curiosity.gem, and then we can talk to them based on their skill set, which grade they are, how much time they have available. So we have mentorships that are 6 weeks long, 3 months long, 6 months long, sometimes even 2 years long, depending on I would say the passion of the student and the commitment. We can take on projects of different size. Even the projects that I've showed you and were part of the quiz, they probably all took different timelines. So yeah.
Okay. So I would encourage all of you to just note down the email ID, and some of you have questions about the cost and the duration of the program. And as Mr. Nair just said, that it depends on the amount of engagement that you want. So just write an email to them. I'll also type down the email ID.
Yes. Sorry, I'll skip it.
Explore@
curiositygym.com. Yeah.
So just write an email to them and just learn more about their programs. Mr. Nair, can you tell about what is the function of the coral structure? That was the very first question which was asked.
Yeah.
And how long does that material last? What was that material exactly, and how long does that last?
So it was a resin-based material, right? So the shape of the mold was made in the 3D printer, right? And then you actually put the resin into the mold, right? And then so it makes a brick-like object that so yeah. So so Siddharth had done research on resins that could last a long time, under deep sea. And not deep sea, but at least under 20, 30 feet of water for long periods of time. Yeah.
Okay. How are you conducting these mentorships online now these days under these current circumstances?
Yeah. So everything that so the coding mentorships, the bioinformatics mentorships, it's just on Zoom, where it's research based. If it's electronics based mentorships, see, to date, maybe even the electronics shops were kind of closed. They were all beginning to open, so we could do these things also online. But the material you could ship it to your home, and then we can figure out how to do it.
Okay.
We also are also teaching some of these things online to schools anyway, using simulation platforms, right? So you can actually have an Arduino, you can actually make a circuit, you can actually do all of the things without a physical Arduino with you, which Arduino is one of those boards which talks inputs and outputs. So you can have the schematic and the programming, all of that done over Zoom. And there are simulated environments where you can simulate, a light going on, or simulate a sound happening, right? All on the screen. It will be the same exact code that would be run on the physical device, right? If you could potentially have those boards also shipped and couriered to you. On some of the 3D printing stuff, we are also taking 3D printing courses even as of date, right? So the student sends the instructor, one of our colleagues has a 3D printer at home, right? And so he gets the file, he prints it out, and he couriers it back to the student. So that's what's up.
Wonderful. And I think in these current circumstances, I think these kind of skills now hold a lot more importance, because probably a lot of students are not able to go to their schools and actually go to their labs. So if the lab can come to them in some form, I think it's a real benefit, it's a real advantage.
Yes.
The next, sorry, please go ahead.
Yeah, go ahead.
So the next question is about which all programming languages do you teach? And there is something about how do I enroll in ROSA through curiosity. Do you have a ROSA program?
Yeah. ROSA is a research-oriented student action, right? So it was on one of the slides. So I'll bring it up again so that. Yeah, so the thing on the left is what she's referring to, right? So it's
Actually,
a one-on-one.
I think your screen is not shared.
Oh, it's not shared now. Sorry. Is it shared now?
Okay. Yes. Yes.
Yeah, the thing on the left is the ROSA program. So it's depending on the project you want to work on. Maybe you want to work on something on a UN sustainable goal, right? So we talk to you. One of our mentors would talk to you, figure out what the problem statement is, then help you on primary and secondary research, and then then we can design a prototype. Depending on the time available, or it can just go into a paper, theoretical paper, what could be potentially done, right? So depending on the time available, you could sign up for a 6-week to up to a 2-year thing. The duration would depend on the time of the student. Yeah.
Okay.
And our costs are usually based on the time that you sign up for.
All right. Which all programming languages do you teach or do you engage in?
Yeah. So we primarily teach Python for the Python and Arduino are the two main programming languages that we have.
Okay.
Arduino for the electronics and hardware kind of stuff, right? And then Python for a regular coding thing. If you want to do some mobile app development, we do have mobile app in MIT App Inventor for more basic applications. So for example, one of the students last year had done an app to, which might be very relevant in these COVID times, is to hook up, people who had to donate food with people who who could donate food, right? So he was hooking up. Suppose you had a party and you had extra food, you could just call this number, and then the person who's coming to pick up, you could give the location of where you wanted to pick up. So it was kind of like instead of a Uber cab thing, it was like hooking up people who wanted food and who could donate food, right? It was a simple mobile app, but that was one of the mentorships that one of the students had done.
Okay, wonderful. How can a school connect with you, and what kind of an engagement can you begin with a school?
Yeah, for schools, we can run. As I said, we are running these innovation hubs in leading schools like Cathedral and Campaign, St. Mary's, and many other schools, right? We've been running this program for over 5 years. So we have a year-long program from standard 3 to standard 12, right? You saw some of the pictures of standards 12 to 12 students. In fact, we have a program even for college students. We could also sign up for smaller things like workshops or summer camps and things like that. All of this is now being done online. So if you go to our website, we have a lot of online courses on a wide variety of things. So maybe I can, in fact, even show that, right? But those are just courses rather than one-on-one mentorships, right? So we have things on Python, data visualization. One second, let me just pull that up. I'll just stop this share.
Yeah.
And coming back to your question about how schools can engage, you can just, or Devesh, if you can pass me the contact of the people who are interested in the schools, that would be good. And then, we can get in touch with them on.
Actually, that question was asked anonymously, so I'm not sure who asked that. Can you, if someone who asked the question about school, can you just, if you can share your name and email, I'll just connect you with Mr. Nair.
Yeah. So on schools, we have these things called innovation hubs. Right? So these are all the courses that we have. One second.
Yeah.
So I'll just take you. You can see my screen now?
No, I can't see it. Yes.
Okay, great. So yeah, so we have a bunch of online courses on STEM, on coding, on mobile app, STEM for senior school also. Where here we teach a lot of things for on applied simulation systems, right? So whether it's biology or physics, we can make it interesting for schools to kind of teach in a very different way, right? And also students can participate individually as well over here. We also have a course in product design and 3D printing, or in AI and data visualization, in bioinformatics, in Python and data visualization, and in virtual robotics. Virtual robotics, in fact, you can even start at a much smaller grade. Right? So this is the courses. Then on the mentorships, I think I talked a lot about during the presentation, but I can just show it to you again.
Yeah.
Yeah, so these are some of the colleges that our students have gone to, right? Urbana-Champaign, Purdue, Harvard, CMU, Columbia. These are just a few of them, right?
Right.
And then on the Innovation Hub is where we run a CAS program for the higher grades for the 10th, 11th, 12th, right? And then from 3rd to 8th, we have a program that's through the year, through the term. It's called Innovation Hub. So it's like a makerspace. So some schools give us a room, and we get the 3D printers and all of that. And this was all pre-lockdown. Post-lockdown, we are still delivering it to the same schools all online, right? So we've changed the sessions so that we don't expect any materials to be there that is not available at home already. Might have simple things like a paper or a piece of cardboard or some things that, just to make it interesting for the smaller grades sometimes. But for all other grades, we have activity-based things which may have simulated environments. So it's very engaging.
Okay. I have a few more questions coming in. So what happens if someone comes to you with a partially built project, like they have already done some part of the work? What do you take it forward?
That should be fine, as long as they think they can benefit from our mentorship. We have no problem with this,
Okay, wonderful. Do you also undertake mentorship in chemistry, nanotechnology, medicines? So 3 different fields.
In these 3, we don't currently take mentorships in.
Okay.
Although Preeti has an interest, who's on this thing. She has an interest in chemistry, but yeah, we haven't started doing that yet. Okay. But you can talk to us. Maybe we have the skill set to do it. We have not taken it yet because so far, the moment you're doing chemistry, you might also need the chemicals and the setup needed in the lab. Maybe this thing. If it's a theoretical thing, it potentially could be done.
Okay. Can you explain a little bit about the whole process of mentorship? Like, let's say we come to you with an idea. What happens after that?
Yeah. So we brainstorm on the idea. Then we kind of scope out the idea. Usually we involve the student, the parent, and us, right? The mentor, and perhaps me or my co-founder Jangi, right? So usually it's 4 people involved in agreeing on the mentorship, because the mentorship is not only on the project but also on the project scope. How long is it going to take? Is it realistic to do it? Is it realistic from a time perspective of the student to commit to that much time? Right? Our charges are always based on the contact hours that you'll have with us, right? Not so you may have spent an hour. Typically we used to spend students, when they used to come prior to the lockdown, they used to come to our space for 2 hours a week. So we are committed to doing that, or potentially sometimes. So we even have something called an express mentorship. There's some kids who are in the 12th grade and they still want to get the app done. They say, no, I have 6 weeks or 3 months before I can do it. So we're happy to do it multiple times a week. Then our charges are always based on the contact hours that we have.
Okay. There is one question.
So coming back to your question, we would brainstorm on the project with the student, get buy-in from the parent on the scope, right? And on the realistic thing from both the cost and the time perspective. And in what our experience has been, a lot of times parents and students say yes, but in the end they say the student doesn't have the time. So we have to make sure that the time is available for the student. And then if they are committed because they want to put this on their portfolio to get into this thing, that's when the thing happens.
Okay. There is one question about the iron thruster. What does it do and how?
Okay. So what the ion thrust is a longer answer. Maybe I'll take it towards the end, but it's basically a physics concept of ionizing particles. And because of ionizing particles, and because it's a very high voltage ionization, with very few particles, you can actually, it's like a, see, let's say you're doing sending SpaceX up to space. You have a lot of LPG, liquid petroleum gas to push it up, right? So, but in once the first two stages of the rocket have gone off, you don't have that much fuel left, right? But you still want to guide the fine tuning of the guidance, right? So there, what you do is you have a high voltage. You have the ability to create high voltage, and you can still create a little bit of tailwind by pushing it's practically vacuum, but it has a few particles of air, right? And that gives you a draft to move the thing forward with minute amounts, right? Okay. So this was a prototype on that, yeah. And it was able to move that thing on the slider, even in the lab.
Okay.
Yes.
How to enroll for your workshops or how to begin engagement with you? And is there a admission process? How do you select the projects that you want to work with?
Yeah, so you can just write to us at explore@curiositygym.com if you want to sign up for a mentorship. If you want to sign up for one of the online courses, you can just go to our website and sign up, and it's there.
Okay. When going to Curiosity Gym, do we have to have a proper idea of our project, or will we have a time to brainstorm with our experienced faculty?
Yeah. Yes. So usually 80% of our students do not have an idea when they come in, actually.
Okay.
I would say, in fact, maybe 85 to 90% of students do not have an idea or a clear idea. Sometimes they may have 3-4 ideas, but they have no clue which one to do, right? So one is filtering out, and sometimes just, and then some students, maybe 30% of students, especially if they're in the younger grades, they may say, we may ask them not to jump into a mentorship straight away and we'll say, learn product design and 3D printing, learn Arduino programming and things like that, learn Python programming. So you have a little base and then you jump into a project rather than jumping in a project and then this thing, right? So you could do that as well, right?
Okay.
If you already have some of the skills, and many of our students may have some of the skills already, but you still don't know what the project is, then our mentors will guide you on something.
Okay, right. But if someone comes to you to learn a particular skill set,
yes,
they are very much welcome to do, right?
That is also okay. Yes, absolutely.
Right. Because that is one of the questions which says that, like, I'm interested only in Python, learning Python. So is it possible to enroll just to learn that particular skill?
Yes. So that you can actually, there are 2 ways of doing that. You can go to our website and just sign up for a course. The course may have more students, more than one student, or may have this thing, right? If you want a customized thing just for base, you may have done some Python yourself, depending on where you are. If you want a customized thing, you can have a one-on-one mentorship, which is more expensive. If you want to do the courses that are there on our website, you can sign up anytime.
Okay. Okay, this is another question. If one is interested, should they start working on mobile application at an early stage, or can it be achieved in a shorter period of time?
Yeah, I'd be interested in which grade is the student who was asking this question.
Okay, again, this is an anonymous question. If the student can simply mention a little more about what they meant by the duration of course, it would be great. Do you also cover Swift language, coding language?
No, not yet. No.
Okay.
So on MIT App Inventor, which can be used for simple mobile applications, it's relatively easy to pick it up. So a ninth grader and above can probably pick it up in a couple of weeks. I mean, of course, simple ones you can do in a day, right?
Okay.
So we can, but if you're making an app that is a little more complicated, has databases, looking at something called a JSON file, whatever. So
it takes a little longer.
Yeah.
Okay. How would you differentiate your courses with courses on Coursera or edX?
So mostly the things on Coursera and edX might be self-study courses, right? Our courses, mostly for the mentorships, all instructor-led. So you're actually talking to a person who's knowledgeable about the field, right? And is answering the questions that you have. So we are very personalized, and we, mostly from very good colleges from India and abroad. Yeah.
Okay. So you just told about ion thruster. Are there any other ideas which are related to space related programs that a student can work on?
So why don't you write to us and then we'll discuss.
Okay. How long does it take to learn Python?
So we have a 8-week course, I think, or eight session course for the first level of Python. Then it's on our website. You can also have a longer course which also has things called Python and data visualization. I think it's a 20-session course, right? And those are not one-on-one mentorships, but you can sign up for the course. There may be other students as well, but it's got a very good instructor, and in fact, he used to set the National Physics Olympiads also.
Okay, wonderful. Another question is, you have a course called Mobile Application Development. Can you elaborate a little more on that?
Okay. Give me a second.
Yeah.
The mobile app development course is, I would say, it's more catered to the smaller grades in the 6th to 8th grade level. If we're using MIT App Inventor, maybe a 9th grader writing a simple app that still is addressing a social cause could probably use it, right? And so, yeah. So I would say it's probably used for more simple apps on the mobile.
Okay. So talking about the different courses or the different programs you have, what is the time commitment that a student needs to give to engage well with you?
In the ideal world, the projects that I showed y'all and we had the quizzes on, they all probably took 6 months, 6 to 9 months. The ones that I showed you, right? These courses, you'll have the number of sessions here. If you're doing a course, and this is not a mentorship, right? And these are 12 sessions. Sometimes it's twice a week, or even thrice a week in some cases, right? So it's very, it doesn't take that long. It's usually in less than 3 months. Okay.
Okay.
Right. For these courses, for the mentorships, depending on the scope of your project, it could be between 6 weeks. If it's, if we are meeting multiple times a week, right? Typically we allocate 2 hours a week, because we know that the students' school schedule itself is also pretty busy. They have their homework, they have the other project assignments. This project is not the only thing they're doing. But in some cases, maybe some IB schools, which are starting in, let's say, August or mid-August, they may have a time where they can really sprint in the July-August timeframe, right? Meet maybe 3 times a week. So we're happy to do that as well. So they can compress a 3-month program into a 6-week program.
Okay. This is a unique one. Can we create an application only using Python? Now, I'm not sure if that is possible.
Yeah. So see, the word application, right? One thinks that an application is only a mobile app. And a lot of your questions, if it's coming from the same person, applications are not only things that run on the mobile. Applications are typically, by the way, even your refrigerator is an application in one way to it. That's a physical application, right? Every piece of software, Facebook is an application, Google is an application, right? Now there are pieces of applications that are client-based and then server-based. Things that you see on a website, for example, are all on the client side. And then there's things at the back end, which is called the server side, right? So depending on what you want to do in your program, is it a standalone program that only resides on your mobile, right? That may be one type of application. Another type of application, maybe Google. Google is an application that Sergey and Larry Page, they wrote two kids. They were, probably done PhD at Stanford, but while they were students, right, they wrote an application that it really didn't have a user interface. The only user interface was one field. Type your search thing here, and that never changed actually all these years, 25 years, right? The application was all at the back end, and you never see it. Their sort mechanism, their page rank, all of that is residing on the server, right? Then they figured out they can't put it on one server. They got to put it on 1,000 servers or 10,000 servers across the world, so that all these users can keep searching. So yeah, so the word application is perhaps not understood well by even computer science students, right? Or so application is, it depends on what application. So Python is good for the backend or for processing data, which is why it's probably even on Wall Street. I have many friends on Wall Street now who use Python even for their finance applications. Okay, right? And there are now different libraries that Python has that makes the language richer. There are things like NumPy and so lots of statistical numerical packages that are add-ons to Python. You're still using Python as the core and then using all of that, right? Now, but the application that, let's say, a Morgan Stanley uses, or one of the financial thing on the website part is one piece of it. The backend thing, which is doing the work, crunching the data, is another piece. Python is good for that crunching and maybe even visualizing data to a certain extent, right? Not that great on the UI side. Yeah. Maybe for charting it is. Yeah.
Okay, wonderful. So we are almost coming to the end of the webinar now. If there are any other questions, I would recommend all of you to just write to this email ID, explore@curiositygym.com. And any final words, Mr. Nair?
No, I think that the final words I would have was on my last slide, right? Is, if you continue to be curious, you'll innovate, right? So that's the main thing. The other thing is, while we are talking about building your college profile and all, I would say that you take that, but let that not be your only mission in life, right? Even more important than that is for you to love what you do. Okay, that's perhaps more important than putting something on a CV and things like that. So if you're passionate about what you do, everything else will come. You'll get into a great college if that's one of your goals, right? But there's no point in doing something for the sake of something, and then you get into the college even, and then you say you don't like what you do. So you must follow your passion. That would what I would say.
Absolutely.
And it's perfectly okay to, sometimes you don't know your passion yet. In fact, I would say 75% of students who come to us may not know their passion yet, and that is fine, right? So we are a platform to help you explore your passions, right? And that is okay. Yeah.
Wonderful, wonderful. Thank you so much, sir. And it was a pleasure connecting with you, learning so much about Curiosity Gym.
Our pleasure. My pleasure.
I hope some of these students will get curious and write to you, learn more about your programs and your projects.
Thank you so much. Yeah.
Great.
Thank you all for attending. Yeah.
Great. Thank you everyone for joining in. Bye.